So we've got some simple sums here, all including decimals, and we want to solve them. So we're going to basically go through each technique for addition, subtraction, multiplication, and division. So the first numbers are 246.2 plus 39.71. Whenever we set up decimals, it's important that the hundreds are always under one another, the tenths are under one another, so the easy thing to remember when it comes to setting up decimals is make sure that the decimal point is under itself. If the decimal point is under itself, then all your numbers are in the right place. So here I would put 39.71. Now my tens are under one another, my units are under one another, my tenths are under one another. There's nothing here above the 1. What does that symbol symbolize?
0.
A 0. So now I've set everything up right, now it's just to add the numbers. What side do we start doing when we're adding numbers? Right hand side or left hand side? Right hand side, exactly. So when we're starting with addition, we always start from the right hand side. So now I add 0 plus 1 gives me 1, 2 plus 7 gives me 9. Decimal point stays in the decimal point stays in the same place under the numbers. Now we're adding 6 plus 9 giving me 15. The 5 goes down here, the 1 from the 15 goes up here and is added on to the next set of numbers. So then we have 1 plus 4 plus 3 giving us 5 plus 3, 8, and 2 plus, here there's actually no hundreds, so it's 2 plus 0 giving us 285.91. Agreed? Yeah. Okay, let's look at the next one then. That was a simple addition with decimal. Most important thing, make sure the decimal point goes under itself. Then you'll have the numbers set up correctly. Now we have 246.9 minus 19.24. Again, the decimal point has to be under one another. When there's nothing here after the 9, it actually means that there's a 0 there. Because it means there's no hundredths. Okay, there can be, we could carry on writing this, both of these numbers, to infinity when it comes to the decimal zeros, but we don't need them. But we do need the one behind the 9, so we'll include that. And now we can start our division. We have 0 kronas, and we would like to take away 4. Can we do that? No, we don't have any. So we have to borrow 1 from here. So it's almost like borrowing a 10. This then becomes an 8 because we've borrowed 1. And the 1 that we've borrowed there goes there and turns this one into a new number, the number 10. So we now have 10 kronas take away 4. Can we do it now? Yeah. Yeah. 10 take away 4 is 6. And we just carry on with the next numbers. 8 take away 2 is decimal point, same place. 6 take away 9. Can we do it? No. We need to borrow 1 again. So we borrow 1 from the 4, turning that into the number 3 now. And we have now number 16. 16 kronas take away 9. Can we do it? 7. 3 take away 1, 2. 2 take away 0, 2. So we have an answer here, 227.66. Is it right? There we go. Subtraction with decimals. Again, both addition and subtraction always start from the right-hand side. Next number then, multiplication with decimals. We now have 79.6 multiplied by 4.7. When it comes to multiplication, which side do we start from? Right-hand side. Always right-hand side for addition, multiplication, and subtraction. When it comes to multiplication with decimals, we ignore the decimal point all the way through until the very, very end. So we actually pretend that we're multiplying 796 by 47. So we're starting with the right-hand side, and that means that we start with this number down here, the 7, and we multiply this 7 by all the numbers in the row above. So the first thing we do is 7 times 6, giving us 42. The 4 I carry above here. You usually write it down there. Yeah? but I carry it up here, and this is what I call my addition line later. I don't use that for multiplication, I use it for adding on later. So now I've got 7 times 9, giving me 7 nines are 63, plus the 4 on my addition line. 63 plus 4 gives me 67. 67. The 7 goes here, the 60 carries on to above the 7. Then I have 7 sevens are 49, plus the 6 from my addition line. 49 plus 6, 55. Yeah? Right, so now I finish multiplying my 7s by everything. The 7 is multiplied by everything on that row. Now I move down and multiply the 4. But what do I do before I do that? I put in the magic 0. So I put in this invisible 0 here. I've moved one step to the left. This number is a factor of 10 times bigger than that number. So that's why I have to move one step to the left. Whenever I go down, I put in this 0 here to remind myself that I'm actually multiplying a number that is a factor of 10 larger than the number I just multiplied. And now I just do my multiplication again. So I take away these help numbers because it's going to be totally different ones now. And now I multiply. 6 fours are 24. 24. 2 there and the 4 here. So wherever I've got 20, it goes over to the next one. 4 nines, 36 plus 2, 38. So 38. And then the last one, 7 fours are 28 plus 3, 31. Totally ignoring the decimal points, not incorporated them at all yet. Right, what do I do now? Now when I've multiplied my 7s by everything and my 4 by everything, and I take this whole list of numbers, and it could be a lot more numbers if we'd had hundreds on the bottoms and thousands on the bottoms, we take them and we just add them together. So we got 2 and 0, 2, 7 and 4 giving us 11. Here we use the same method as for addition. We carry over the 1 from the 11 to the next set of numbers. 8 plus 5 plus 1 giving us 8 plus 6, 14. The 4 goes here, the 1 goes here. 5 plus 2, 7. 3 plus 0, 3. Right. Is that the answer then? Is it reasonable that 79 times 5 is going to give us the answer 37? No. So we have to go and look back at our initial question. And we have to say, how many numbers were there after the decimal point in our question? There was one number after the decimal point here, and there was one number after the decimal point here. So there were 2 numbers behind the decimal point in our question. So we put our decimal point 2 places back in our answer. 1, 2. That's the final answer. Is that reasonable? 374.12 would be our answer. So multiplying with decimals isn't complicated. You pretend that there aren't decimals there and then put the decimal point back at the very, very end. Right, let's do some division then with decimals. Here we have 13.2 divided by 4. There's a decimal point on the top. Do I need to do anything to change the number if there's a decimal point on the top? No, you really don't. So decimal points on the top, don't multiply both by factors of 10 or something silly like that. Decimal point on the top is super. But where do we start when it comes to division? Right-hand side or left-hand side? Left-hand side. So division is the only mathematical method that starts on the left-hand side. Everything else starts on the right-hand side. So we have to do 1 divided by 4, where the top number here is number of sweets, and the bottom number here is number of happy children hoping to get a sweet. Okay? So we got 1 sweet and 4 kids. How many sweets does everybody get? None. So we move that 1 over to the next number, and we now have a new number. We now have 13 sweets and 4 kids. How many sweets does everybody get? 3 sweets each, and how many were left over? 1 was left over, because 4 times 3 is 12, and we had 13. So 1 is left over. Before we divide this 12 by 4, we put the decimal point in exactly the same place. So we're not allowed to divide this 12 by 4 till we put the decimal point in the correct place. 12 divided by 4 is 3, giving us the answer, 3.3. Okay? So dividing with decimals on the top, piece of cake. What about here then, when we've got 471.3 divided by 0.6? Are we allowed to divide with decimal numbers on the bottom? No. That's a big no-no, yeah? So what do? We multiply top and bottom, in this case, by 10. If we multiply top and bottom by 10, we get on the top 4,713 divided by 6. These two numbers are exactly identical. If you put this set of number into the calculator, you'll get exactly the same answer as you would. So they're called sort of equivalent fractions. They're exactly the same thing because you multiply top and bottom. And now we can just do the division. 6's into 4 don't go, so we get 6's into 47. 6's into 47 go, 6 7's are 42. We had 47, we know that 6 7's are 42, that means that we've got 5 left over. The 5 go over to the next number. 6's into 51. 6 8's are 48. So 6 8's are 48. And we had 51, so how many's left over? 3. 6's into 33. 6 5's are 30. So it goes 5 times. How many left over? 6 5's are 30 and we had 33. There's 3 left over. What do we do now? We need to put in our decimal point, don't we? So this number, 4,713, is the same as 4,713.0000. So we now have a decimal point here, which we must put in our answer as well. And we do our final step of 6's into 30, giving us 5 times. So to divide 471.3 by 0.6 by hand is not difficult to do. Okay? Everybody understands? Addition, subtraction, multiplication, and division with decimals.